In this video, we are going to talk about sets and Venn diagrams, two very important notions for kids to understand in order to be able to solve various math problems. Okay. So first of all, what are sets and Venn diagrams? Sets are just collections of objects. Okay, and Venn diagrams are just visual representations of sets. And they're very important actually because most of the time when you encounter a new notion in math, you have to have a visual representation of it so that you get the visual help of what's happening. Okay, let's see how we can actually use sets and Venn diagrams in order to solve some math problems. So let's take a look at this problem. The problem says that there's 25 kids on my street. 15 kids go to the math club, 12 kids go to the chess club, and 5 kids from my street do not go to either club. Well, as you can see, there's no question asked yet, and that's done on purpose because what we want to do is, first of all, we want to get a good understanding of what's happening here, okay? And actually, we will end up answering more than one question, okay? Let's see. So the first information the problem gives us is that there's 25 kids on the street. How can we represent that? Okay. Well, one idea would be maybe to draw a nice rectangle. Okay. With the intention of saying, okay, the 25 kids are going to be represented inside this rectangle. Okay. Let's call this rectangle S from street. Okay, so inside here, we're going to represent the 25 kids. What else is the problem saying? Well, it says that 15 kids, so 15 of the 25 go to the math club. How are we going to represent these 15 kids? One idea would be to maybe draw a circle inside the rectangle we called S. Let's call this circle M. From math, okay? So inside this circle, we are going to represent the 15 kids that actually go to the math club, okay? What else is the problem saying? Well, the problem says that 12 kids go to the chess club. So we represented the 15 kids that go to the math club with this red circle here. If we actually try to represent the 12 kids that go to the chess club with a circle, let's say in this area, so that this circle will not overlap the circle with label M, well, what we are going to have is we are going to have 15 kids that go to the math club, and these are the 12 in this area, so we already account for 27 kids. Well, we already have a problem in the sense that now we account for 27 kids, but there's only 25 kids on the street. So how can we deal with this problem? The only way to deal with this problem is that we have to represent the kids that go to the chess club, say with another circle, this green circle. Okay, let's call it the circle C from chess. But this green circle will have to overlap the red circle. Otherwise, we will represent already 27 kids, which is more than 25. Okay, so now we kind of found a way to represent the kids that go to the math club and the kids that go to the chess club. How about the 5 kids that do not go to either club? Well, the problem actually makes it easy for us in the sense that if we represented the kids that are on the street in this big rectangle S and the kids that go to the math club in this circle M and the kids that go to the chess club in the circle C, what happens is the kids that do not go to any club can be represented in this area here that we shade with purple, just because that's all the problem is telling us, that these 5 kids do not go to either club. So already we can tell that inside this area that we shaded with purple, we have 5 kids. Now, well, what can we do? We have the 5 kids that do not go to either club. We have the 25 kids that are on the street. So the 5 that do not go to either club give us 20. And these 20 kids go to either the math club or the chess club. So actually, if we go back to our diagram, where are we going to represent the kids that go to either the math club or to the chess club? It has to be inside this area here. Okay, so inside this area here, we have to represent 20 kids. But if we add the number of kids that go to the math club, which is 15, plus the number of kids that go to the chess club, which is 12, we end up with 27 kids. So how can we represent in there 27 kids when we know that there's only 20 kids in that area? So there must be some counting that we have to be very careful with. So I would suggest that you pause the video now and you figure out how can we explain the 7 extra kids that we get when we add the 15 kids that go to the math club with the 12 kids that go to the chess club, and how come we get more than 20 kids that go to either the math club or the chess club. So I hope you pause the video and you actually have an answer to that question. My answer to the question is the following. When we add the 15 kids that go to the math club and the 12 kids that go to the chess club, actually we double count some kids. Okay, so actually we double count the kids that go to both the math club in the 15 and the kids that go to the chess club in the 12. So that's how we can explain the difference between the 27 and 20. So what that tells us is that there's 7 kids, which is exactly 27 minus 20, 7 kids that go to both the math club and the chess club. Okay, so already just by looking at this diagram, we figure out a very important information about what's happening with these kids on my street. Namely, 7 of them go to both the math club and the chess club. Now with this information, what can we do? Well, if we go back to what the problem is telling us, we know that 15 kids go to the math club. We already accounted for 7 of them, namely the ones that go to both the math club and the chess club. So the remaining kids of the 15, which is 8 kids, go only to the math club. Also, now when we go back to the problem again, of the 12 kids that go to the chess club, 7 go to both the math and the chess club. So 12 minus 7, which is 5, go to only the chess club. So now, I would think we learned quite a few things about the problem. And namely, we learned that 8 kids go only to the math club. 7 kids go to both the math and the chess club. And 5 kids go only to the chess club. Okay, so if we actually do some math now, just to double check the work we did before, 8 plus 7, 15 kids go to the math club, which is fine. 7 plus 5, 12 kids go to the chess club, which is fine. And 5 kids do not go to either club. So just to summarize, just by actually coming up with this Venn diagram, we get a visual representation of our problem that helps us understand exactly how many kids go to only the math club, how many kids go to both the math and the chess club, and how many kids go to the chess club only.